So the amount of data we create and store is actually exploding. Currently, the global data sphere is estimated at 180 zettabyte of information. 1 zettabyte of information is equivalent to 2 billion standard laptops. And nearly 65 to 70% of this data is actually cold data, data which is stored, but rarely or almost never accessed. The current solution for cold data storage is magnetic tape. Magnetic tapes are very inefficient. First of all, they are non-durable. They have a lifespan of just 10 years, 10 to 15 years. They are unsustainable because they require high energy consumption, and they require very large physical space. How big? Think about 5 times San Francisco big to store just the cold data that we currently have in the world. But what if I told you that we can take these 5 San Franciscos of data centers and shrink them into a shoebox using tiny and stable storage device? So we can actually do it using nature's earliest and strongest data storage device, which is DNA. So how it's going to work? We have DNA synthesis, which is the process of generating artificial DNA strands. In this way, we can encode information as DNA sequences and then generate artificial DNA molecules based on the sequences. So this is kind of writing into our storage device. And when we want to read and retrieve back the information, we can use DNA sequencing to read the sequences of the DNA from the molecules and then decode them back into our information. So why to use DNA as a storage medium? So I've mentioned earlier it's high capacity. It's million to hundreds of million denser compared to current storage device. It is extremely durable. It can last for a million years. It is a sustainable solution, very green, because it requires near zero energy for maintenance and storage, and it's very easy to replicate for backups. So the archival data storage market is actually a huge market that requires transformation, currently estimated as $51 billion, with a small portion of DNA data storage, $320 million. And it has expected CAGR, expected growth of almost 60% for DNA, meaning that in 7 years, it's gonna look entirely different, and and this market is gonna be dominated by DNA. And I believe that we are the right team to build this DNA data storage project. I am Omer Tzabari, I'm the CEO. I'm an expert in retrieval algorithms and nanopore sequencing. We have Professor Zohar Yechini, which is an expert from the Technion in DNA synthesis and bioinformatics. And we have Professor Eitan Yacobi, expert in error correcting codes and algorithms and constraint codes. And so far, we have worked at the Technion on academic proof of concept, and we have 3 patents for retrieving and encoding information in DNA using error correcting codes. Currently, we're working on developing IP strategy and company founding, and thanks to our journey in Road 2 and technical validation that we have with potential customers, with early adopters, we decided to shift our focus and to work on the missing piece of the puzzle, which is DNA synthesis, or reducing the cost and latency of DNA synthesis. And we are able to provide MVP by the end of next year for one of the applications that we are working on. So now we are fundraising to recruit our dream R&D team. We are looking for hands-on synthesis experts, bioinformatics specialists, and of course software engineers. And we also would like to connect with archival storage experts to help us reshaping the market. Thank you.